Hello, welcome to Michael Shelton's Tech Tip number 3 on Acoustic-Induced Vibration, AIV. In much the same way that an opera singer can acoustically shatter a wine glass with her voice, so can process piping systems fail due to acoustical loading. What might appear at first to be a mighty force ripping through the piping system may be something quite a bit less threatening in real pressure terms. Let's look at the reality to understand acoustic-induced vibration and the real magnitude of the mechanism that is in play during an acoustic event in any piping system. Now, Mr. Shelton, to discuss AIV in terms we understand.
Thank you, John. Acoustic-induced vibration, AIV, results when a gas flow experiences a large pressure drop from a flow resistance, such as a relief valve, orifice, or choke. The energy released from the kinetic energy per unit volume of gas, which is just psi for pressure, of the flow stream is conserved by conversion of that energy to sound power in the downstream flow. This newly created sound power will present a very large broad band of frequencies. The downstream gas flow is coupled with the piping wall where some of the broadband frequencies will match the pipe wall natural frequencies, producing resonance in the piping. The pipe wall coupled to the gas flow will in turn excite the gas flow itself. The gas flow itself will have resonant or natural frequencies as well. The greatest propensity for failure comes when the gas flow acoustic resonance frequency matches the pipe wall natural frequency. Well, as John was pointing out, how much energy is involved in a typical AIV event? The Energy Institute limits the decibel level, for no further analysis required, to 155 dB. This 155 dB equates to 0.163 psi acoustic pressure. Now remember, a person can only blow 2.8 psi through their mouth. A space shuttle launch will produce 195 dB, which is equivalent to 16.3 psi pressure. It is clear that a very low kinetic energy sound pressure, about 1/17 of what a person can blow, when in resonance, can produce acoustic fatigue. Most AIV issues occur in plant relief systems. Since relief systems are normally used in plant emergencies, a catastrophic acoustic fatigue failure would present a serious issue, since the affected relief system may not be able to be shut down quickly. AIV is a serious issue. When the decibel level exceeds 155 dB or 0.163 psi sound pressure, the Energy Institute's guidelines for avoidance of vibration-induced fatigue failure in process piping requires a full assessment of the piping system to determine the associated likelihood of failure, or LOF. Should this LOF, or likelihood of failure, value exceed 0.5, additional analysis are required. I, in conjunction with ANSYS, have developed highly advanced proprietary tools dedicated to performing these EI calculations to assure safe operation for all sound power levels. These tools encompass the application of EI to any acoustic source, to subsequent EI-directed advanced analysis including full remediation for AIV impacted piping systems. So, looking back, we can see that 1/17 of what a human can blow can cause failure in a piping relief system, a serious situation. Stay tuned for our next tech tip number 4, high temperature hydrogen attack, HTHA inspection methods. See you there.